Can you see the screen?
Yeah.
Aditya is in mute or something? Because he is there in the call.
Yeah, he's there.
Doesn't want to speak anything actually. Hope Aditya you have seen the previous videos. But today I'm going to start with improper integrals first because that's something which we missed out. No, we can't hear you.
Hear me now?
Yeah, now I can hear you.
Yeah, no.
Okay, just a sec. It's quiet now.
But you're very, very feeble. Very feeble.
People, yeah.
Huh? Yeah. Okay, I don't.
All right. So improper integrals.
See now?
Yeah, we can hear you, but it's very, very feeble.
I don't know why. I'm in the same place.
Okay. I can manage at least, no worries.
Sir, in yesterday's class,
Yeah.
So you did. There was a question where you used some half GT square thing. Like, what was that?
Oh, that's actually the motion of a body under uniform acceleration. So the formula
how do
is
you
the
figure that?
distance. Yeah, you can note down this formula. Distance is half AT square.
So
Now,
you did minus yesterday.
Yeah, now A is negative G because it is opposing the motion of the body. So if you put it over here, it becomes minus half GT square. So if you throw a body up,
Yeah.
let's say there's a ball which you toss up
Correct.
with the initial velocity of u, right?
Yeah.
Then the distance covered at a given time, let's say after time t, it reaches, let's say from position A to position B. Then this distance s is given by is given by ut minus half gt squared.
So what did you take as ut? So you took like
U is the initial velocity.
Okay, fine. Okay, so you took v naught sine alpha as
V naught
u.
sine alpha is your u for the given question.
I had one more question. Oh yeah, so in that question where you use arc length, like how are you supposed to know to use arc length and not like something else?
It's not a motion along a straight line, right? It was a motion along a curve because x and y are changing with respect to each other by a non-linear function of t, right?
Okay.
So if it was moving along a line, then you can use your, remember one class we had taken finding the s. We used to draw diagrams like this.
Correct. Yeah.
That is the motion along a straight line. But when the particle is moving along a 2D figure, okay, then you have to use the arc length.
Yeah. Yeah, that's it.
Okay. Okay. What is improper integrals? We call actually two types of integrals as improper integrals. One, where at least one of the limits of integration is infinite. Where at least one of the limits of integration is infinite. A typical example would be something like 1 to infinity of, let's say, 1 by x. Okay. Or let's say minus infinity to 0 e to the power minus x. Okay. You can have both the limits also as infinity, but no, let's say minus infinity to infinity dx by a square plus x square. Okay. So here at least one of the limits of integration is infinite. Second type of improper integral is where in the interval a to b, okay, this function f of x has a discontinuity. has a discontinuity where C belongs to the interval a to b. So some point between a to b, the function has a discontinuity. For example, between, or it can be at the corner points also. It can be at the end points also. Okay. For example, this function is not defined for 0, right?
Yeah.
Okay. So this is an example of second type of improper integral, or something like this: 1 to 2, or say, let's say 0 to 2, 1 by x minus 1. So you know that at 1 it is not defined.
Next one.
Yeah.
Getting the point.
Mm-hmm.
So how to deal with?
So C can lie between those two also.
Yeah. C belongs to A and B, including A and B. Okay. Is that clear?
Yeah.
Now, how do I evaluate such kind of questions? In such kind of questions, I'll take an example. Let's say type 1 improper integral where we had one of the limits as infinite. Let's say I take this example. How do I evaluate this? For this, we break the integration as 1 to b, and we put the limit on b as b tends to infinity. So basically, we take the limiting case of the b as b tending to infinity. So we integrate it in a proper way only. So let's say the integration of 1 by x square is negative 1 by x, correct?
Yeah.
And we put those values as normal values. So b minus of minus 1 by 1. That's going to be minus 1 by b plus 1.
Plus
And
one.
then we evaluate the limit of this as b tends to infinity. So what will happen as b tends to infinity? This term will vanish.
Zero.
Yeah,
So it will
zero.
become a
become
1.
one.
It will become
So it's
a 1.
one.
So the answer is 1 in this case. Right? Now, what is the meaning of this improper integral? The meaning of this improper integral is that if you sketch the graph of this function 1 by x square, we all know the graph of this is like this. This is the graph of 1 by x square. Okay. So it says that from 1 to infinity, if you go, this area will still be finite and that value will be 1. Okay. Are you getting this point?
Yeah.
So we
Yeah.
call such kind of integrals as converging integrals. Because even though you are integrating it till infinite value of x, the answer is a finite value. This is a sign of convergence. Getting the point?
Yeah.
But on the other hand, if I give you a question, integrate, take another example, integrate dx by root x.
Mm.
So again, we'll write it as integral from 1 to b
Mm.
and limit b tending to infinity. Correct? So we all know the integration of this is 2 root x.
Yeah.
Correct? So it will be 2 root b minus 2, correct?
Yeah.
Now, as b tends to infinity, in this case, you would realize your answer will become infinity. You have to get an infinite answer. That means this function does not converge, it diverges.
Diverges.
It diverges. That means the area is not finite as b tends to infinity.
Mm.
Are you getting it? So in this
Yeah.
case, actually I'll draw it on the same graph. Your graph looks like a bit this. It'll again cross through 1 only, but it will be slightly above this. So this area now, which is the new area, let's say I shade it with white. This area now will now become infinity. Are you getting this point?
Yeah.
So I would like to take this opportunity to generalize this here because it may be useful for you in the later chapter also, sequence and series. So let me generalize this. And do remember this because it helps us. If you're integrating dx by x to the power p from 1 to infinity.
So my connection is like continuously going. So if I'm not there, it's because of that. Like
Can you see the screen at
one
least?
second. Yeah, it just freezes for a while, like for 10-20 seconds. It's fine now.
Did you do?
Yeah, but
yeah, could you hear me before this?
Yeah, I can hear you. Just that for a while it goes. So I'm.
Oh, okay. Just check the rate at which the packets are coming.
Which okay.
The internet packets.
Yeah.
Okay, now here.
That problem was there before, so.
Yeah, they come in packets actually because the supply is given in terms of packets to everybody because it has to cater to the need of so many people. But since it is so fast, we don't feel that lag actually.
Yeah.
Now the generalization is if this p is greater than 1, such kind of integral will always converge. Okay. And if p is less than equal to 1, such kind of integral will always diverge. Understood?
Yeah.
So if I ask you integral from 1 to infinity of 1 by x, does it converge or diverge?
Converge.
Is diverge.
Equal to 1.
Less than equal to 1.
Yeah, usually it's greater than.
Yeah. So if I say 1 by infinity 1 by x cube, does it converge or diverge? It converges. It converges. Is that fine? So just remember this, it's very useful. Okay. Well, let's take more examples and understand this, how we can evaluate. Now, what about the second type where you see a discontinuity at some point? Again, the same concept. I'll take example of that as well. Let's say I want to evaluate integration of 1 by x cube dx from 0 to 1. Now at 0, you know this function is undefined.
Yeah.
Right? So what we do is we take it from k to 1
limit
and take the limit
k
on
tending to
k tending to 0 plus.
0 plus.
0.
Okay. Simple as that. You don't have to apply. This is very simple. It may sound a bit tricky, difficult to see this expression, but it is very obvious because instead of starting from 0, you are starting from slightly higher than 0. Correct? So what is the integration of this? If I'm not wrong, it's minus 2x square. Correct?
Yeah.
So you have to put 1 to k. So that will be minus 1 by 2 into 1. Okay? And you have to do plus 1 by 2k square. And again, when k tends to 0 plus, this fellow will become huge. Correct?
Infinity.
So the answer will be infinity in this case. So even this integral diverges.
So why can't we take k tending to 0 minus? It will still
0 minus ke pehle to function, you are integrating from 0 spot to 1, right? So 0 minus the function doesn't exist.
Doesn't exist.
okay.
You have to consider your existence of the function within the limits or including the limits, within and including the limits.
Okay.
Okay. But on the other hand, if I ask you to integrate this dx by cube root of x from, let's say, 0 to 1, let's apply the same funda. K tending to 0 plus 1 by x to the power 1 by 3 dx from k to 1. Okay. So if I'm not wrong, integration of this will be 3 by 2 into x to the power of 2 by 3.
2 by 3.
Yeah. So that will become 3 by 2, 1 minus k to the power 2 by 3. Correct? Now, as the limit k tends to 0 plus, the answer for this will become 3 by 2. And now you can see it is converging here.
It's converging.
It converges here. Okay.
Yeah.
So let me take this as an opportunity to give you a rule here itself, because it may slip out of my mind. If you are integrating any integral of the form, let me write a rule over here. if you're integrating any integral of the form 0 to a x to the dx by x to the power p,
It's the
where
other
a
way.
is some quantity which is positive, okay, then this, if p is less than 1, this given integral will converge,
Yeah, it's the opposite of the other one.
and p will be greater than equal to 1, then this given integral will diverge, and exactly as you pointed out, Aditya, it is opposite of the previous one. Is that fine?
Mm.
Okay, so just remember this, very helpful. Okay, now we'll try to gain some more confidence by solving questions on this. So let's say all at least 3-4 questions on this.
So will they just ask divergent, convergent, or will they ask for values?
They may just ask this integral, does it converge, diverge, like that. Is that fine?
Yeah.
Yeah.
Okay. Question number 1. Integrate 0 to 2 dy by under root of 4 minus y square. Do it. None?
Wait, so you apply the limit and then you.
Yeah, at 2 it becomes problematic, right? So we'll take
So
it as
yeah.
0 to k,
From
limit k tending
to
to 2 minus.
Yeah.
Okay. And if I'm not wrong, this actually resembles the integral of this form, under root a square minus x square, right? And we did that as sine inverse of x by, correct?
Yeah.
So this
Yeah.
will be sine inverse of y by 2. Okay, from k to 0. So sine inverse of k by 2 minus 0. And we have to find the limiting case of this as k tends to 2 minus. K tends to 2 minus sine inverse of k by 2 would be sine inverse of 1. And that's pi by 2.
Pi by 2.
Pi by 2 is the answer. Absolutely correct. Okay. Try this one. Integral from 0 to 2 dx by x minus 1 to the power of 2 by 3. Now here the discontinuity is occurring somewhere in between 0 and 2. So how will you write this? See, there's a way to write it. So we'll write it as from 0 to k, where k is tending to 1 minus. Okay. Plus m to 2, where limit on m is tending to 1 plus. Did you get that? Did you get that?
Yeah.
So I broke it at k and said k is tending to 1 minus, and here m tending to 1 plus. Now evaluate it.
Wait, so the previous one, why does it become sine inverse 1?
Because substituting k with 2.
Because you put 2 minus there, slightly less than 2, it will be sine inverse of 1, right?
Wait, no. What it was sin inverse k by 2 minus 0, right?
No, it is equal to, not.
Yeah. Okay. That's what. Yes. That's.
The digital pen sometimes misses writing somewhere.
Yeah.
Evaluate this and tell me the answer.
Maybe 0, right? No. Wait. Sorry.
No, answer is not 0.
No. No. Uh,
Are you facing problem integrating this?
no.
So integration of x minus 1 to the power minus 2 by 3, you just have to follow the power rule, right?
Yeah. That becomes 0.
It becomes this, correct?
Yeah.
Yeah. So 3x minus 1 to the power of 1/3, you are integrating it from k to 0, putting the
This
limit.
k
This
minus
also
1
same thing, 3.
from 2 to m.
Okay. So this will become 3k minus 1 to the power 1/3 minus 3, 0 minus 1 to the power of 1/3.
So the answer is 3, right?
Yeah. Answer is 3 for this. Because this will become 0 as k tends to 1.
Oh, right. Oh,
And
so
this
the
will
answer is
become-
6, right?
Yeah,
Final
this
answer
will
is
become 3. So here the answer will become 3. I'm writing it with bold. Likewise here, when you put a 2, you get a 3. And minus 3, m minus 1 to the power 2 by 3. When you put m as 1, this part will become 0. So again a 3.
6.
So total answer is 6. Okay?
Yeah.
Now, next important concept that we are going to study is the comparison test. What does this test say? This test says that if you have a function f of x, okay, which is known to be less than equal to g of x. Now, what is the meaning of a function being less than equal to g of x? It means when you graph these functions,
fine.
okay, then this graph is lower than this graph. Okay? In a given interval, let's say in a given interval a to b. Okay? So if a function f of x is less than equal to g of x in a given interval a to b, and g of x integral from a to b is convergent, then even integral of f of x from a to b would be convergent. Is that fine?
Yeah.
So if you can evaluate the integral of g of x from a to b, then you can also, and the answer is a finite quantity, then the answer for integral of f of x also from a to b would be a finite quantity. Okay, that's rule number 1 of this test. Rule number 2 is if f of x is greater than equal to g of x in the interval a to b, okay, and integral of a to b of g of x is divergent,
And f of x is also divergent.
Absolutely. Then integral of f of x from a to b will also be divergent. This is something which we normally use if you just have to answer the convergent or divergent nature of some integral. Let me give you an example.
So the convergence in the divergence of the first case nothing can be told about it, is it? Like just like the way we have a relation for convergence, divergence cannot be taken for the previous.
Right. Absolutely, Shreya. For the first one, if let's say g of x is divergent, I cannot say whether f of x is divergent or convergent.
Yeah.
But here I can definitely say if this is convergent, this has to converge.
Okay.
And here also, if this was convergent, I could not comment upon the nature of f of x.
Yeah.
Okay.
Very valid point. And you'll see that this test is also used in sequence series.
So could you give 2 seconds? I need to copy that.
Oh, 1 second. I'm so sorry. 1 second. So Aditya, you voted today?
What? So did you?
No, yeah, my voting ID is of Jharkhand. I'm a domicile of Jharkhand.
So you're going to Jharkhand?
See, if you really see, the upper middle class is least affected by election.
Yeah.
It's only the very rich people or very poor people, for them election matters. But ideally, everybody should vote. I mean, of course, above 18.
But it's like voting between the lesser of two evils. So.
See, if Congress head was not Rahul Gandhi,
yeah,
then people may have voted for Congress.
No, but I would still vote for them over BJP.
But do you think Rahul Gandhi is, capable enough to run a country?
No, but I think like the administration of the Congress party as a whole is way more like.
They are more experienced, of course.
Yeah, and like.
That's why if the face changes, let's say they put like who was from Karnataka?
Shashi Tharoor or someone like that.
Shashi Tharoor or this Karnataka fellow was also there, no? Kharge. Kharge is also very experienced.
Yeah.
But I think if Priyanka Gandhi, they're also thinking of making prime minister.
Yeah. But I don't know. Let's see.
Shreya done?
Yeah.
Shreya is listening to our political discussions.
I can't even do anything about it. When I turned 18, I'm a US citizen. I can't vote here anyway.
Oh, you are an American.
Yeah.
Okay, let's say I give you a question. Is this integral convergent or divergent? Okay, now, if you recall, I had done something with you where I had showed that this expression, if P is greater than 1, becomes a convergent series, correct?
Yeah.
Yes or no?
Yeah.
Now try to recall the same over here. Now, if I ask you 1 by x cube integral from 1 to infinity,
that's convergent.
It's a convergent series, correct? It's a convergent integration. Okay.
Yeah.
And I can see here that
it's lesser than
function. Absolutely, Aditya has got the pulse now. Now this is lesser than 1 by x cube because the denominator is heavier, correct? So if this fellow's integration is converging, even this fellow integration will also be converging. So without much hassle, I can actually claim that this is also a convergent integral. Okay, let's take another one. Tell me whether this integral sec x by x cube from 0 to 1, is this converging or diverging? Recall, this is Divergent,
So-
right?
So you can't say, right? Like what? Oh, right. No, so it's convergent. So that what you wrote is. Oh,
No, no, no.
never mind.
The other case, 0 to a case you see. Let me go back. Yeah. Look at this one. Where I gave the rule here. Oh, it was in the fourth slide. It was in the third slide. Yeah, look the rule over here. 0 to p, p greater than 1, it
Yeah.
diverges.
Yeah, I know. I was seeing the 1 to infinity.
Okay, so greater than equal to 1, it diverges.
Yeah, so it's divergent. Even that one is divergent.
So 1 by x cube integral will also be divergent.
Mm.
Now,
And that's greater than that.
we know that sec x always lies between either minus infinity to
Minus
minus 1.
infinity,
Yeah.
1 or 1 comma infinity.
Yeah. So in the interval 0 to 1, that will
It's
be
not defined.
when x lies between 0 to 1. This will always be greater than 1, right? It will always be in this interval, right?
Correct.
That means, in short, I want to say that this term will always be greater than equal to 1, correct?
Yeah.
So 1 by x cube and sec x by x cube, which is greater?
Sec x by x cube. Which means that
This
it's
is greater.
divergent.
Correct? Correct? So
Yes.
if this fellow is diverging, if the integral of this is diverging, then the integral of this will also diverge. Right? So this will also diverge. Since this is divergent, implies this will also diverge. So answer is it will diverge.
So
Understood?
I don't get the fact that why are you comparing? As in, why are you comparing 1 upon x cube and sec x by x cube?
Which
I
is the
don't-
comparison test. Teacher.
Okay.
So this is
But-
your f of x and this is like your g of x. This is, let's say, g of x and this is, let's say, your f of x.
So, but if suppose you have a function where 1 upon x cube is greater than something by x cube, then you still would say both are diverging, right?
No. If a function is greater than this, then we'll say this is diverging. If something is less than this, I cannot comment.
Oh,
That's what you. That's the question that you actually asked me, right?
yeah. No, just yeah. Okay.
Next question. Determine whether or not this converges. Converges or it diverges. Which option?
So that this is not of the form 1 by
Yeah,
x
this
cube.
is, that's what. You may not get all the functions of the form that we discussed so far. So that is actually helpful in many cases, but not all cases. Acha, had there not been x square, there been x. Can we evaluate this integral?
Yeah, like solve it normally. Yeah.
So, but I thought you mentioned one day that e raised to x graph or minus x will all the area under it will always be 1 or will always be a finite value or something like that, right? Why can we use that?
I mean,
You said the area, yeah.
let the test tell you that. Because in the exam you cannot say no. Akhil said told, that's why. So let the expression or the evaluation of this integral tell you that. Okay. So this will be e to the power minus x by minus 1. Okay. k to 1. So that will be e to the power minus k negative plus e to the power minus 1. Correct.
Mm.
Now limit of this as k tends to infinity. What will the limit of this as k tends to infinity? What will happen to this term?
It
0.
becomes 0.
It will be 1 by. Correct.
Mm.
Now my claim here is that, and try to validate my claim. My claim is that the graph of this will always be lower than the graph of
Of e to the power minus 1.
this function. And why is that so? It's very simple to understand why this is lower than this. If you see, you are integrating from 1 to infinity, correct? So when you are looking in the interval 1 to infinity, which is greater? X square is greater or X is greater?
X square.
X
Say
square.
X square is greater, correct? Okay.
Mm.
Now which is greater? Minus X square or X? Minus X.
Minus X.
Minus
Minus X. So if I
Hmm.
raise a lower value to a power of E and a higher value to the power of E, which one will give you greater value?
X. X.
Mm.
Correct. So this graph and this graph, which will be at a higher level? This will be at a
E to
higher
the
level.
minus X.
Yeah.
And the higher wala, he is converging. So lower wala has to converge.
Yeah.
Right? When the strongest
Yeah.
person is getting defeated, the weaker than that will definitely get defeated, isn't it?
Yeah.
So if this is converging, if this is convergent, then this guy also has to converge because it is lower in value than the previous one.
Mhm.
Let's see as a GeoGebra whether what I said just now that's correct or not. GeoGebra. So yeah. So y is equal to e to the power of minus x. Okay, this is the graph.
Mm.
And y is equal to e to the power of minus x square. Okay, and I'm looking at the interval x equal to 1 to infinity. So after this, just don't focus before this. Okay, after this, if you see, green one is the boss, correct?
Mm.
The green one is always higher than the red one.
Mm.
So if this area is finite, so
That
please
area
note,
also should be finite.
so please note I'm shading the area from green to the x-axis. Then this area will also be finite. Understood? That's the thing that I want to explain in this question. Clear?
So, but yeah, if it was like minus infinity to minus 1, then it two, yeah, something like that, then it would be
Then it
different.
would have been difficult. Then it would have been, really deep analysis would have been required. Okay. Let's take another question. Comment upon the convergence or divergence of this function. It's a very beautiful question. Any idea how to do it?
So you have to find a low function.
Absolutely. You have to see whether you can find a function whose convergence divergence nature is known and it is lesser or greater than this function.
Exactly.
So I'll give you a hint. First, break it up into 0 to 1. And then 1 to infinity, because both the type of limits would be included in 0 to infinity, right? See, we had done two types of, we had done two types of, improper integral whose convergent divergent nature was known, right? One was of the form 0 to a, another was of the form 1 to infinity, right?
Yeah.
That's why I'm breaking it up like this.
So you're doing this in 0 to a form.
Okay, yeah, let's check on this first. Let's go step by step. First, focus on this guy first. Okay. Now 0 to a, you recall, what did we do? 1 by x to the power p dx. Okay. What did I discuss for this case of integral?
If p is greater than 1, then it's greater than equal to 1, then it's divergent.
See, we discussed here that if p is less than 1, it converges.
Yeah.
Yes,
Here it is.
And if p is greater than equal to 1, it diverges.
Divergent.
Okay. Now see here. When you are in the interval 0 to 1, remember you are dealing with fractions. Right?
Yeah.
You are dealing with fractions.
Yeah.
Now tell me, when you are in the interval 0 to 1, which is greater? X plus x to the power 4 is greater or x is greater?
X.
Hey, still this will be greater, right? Because you're adding some more.
Oh, sorry. Oh, yeah.
Correct.
Yeah.
So whose root will be greater? Of course, the root of the greater will be greater than the root of this. Correct.
Yeah.
But when you reciprocate this, what will happen?
Exactly.
1 upon root x will be greater.
That's correct.
Therefore, yeah. And that one is
root x means p is equal to half.
Yeah. Which means that's one.
So if this guy converges,
so that one also has to.
Then it implies that even this guy will converge because it is lesser than the 1 by root x function. So this will also converge. Okay. So this will converge. But this is just half the job done. Now I have to focus on this yellow guy. Can you similarly reason it out? I've given you half the hint.
Okay.
So just recall 1 to infinity, 1 by x to the power p dx.
If p is greater than 1.
Right? And I've given you that when p is greater than 1, it diverges. When p is greater than 1, it converges.
It converges.
And p is less than equal to 1, it diverges. So now again, in the interval 1 to infinity. Yeah, Aditya, tell me.
So the function will be, we just said.
Can I say this will be again greater than this?
Yeah, therefore the roots are greater and therefore the reciprocal is lesser. And 1 by root x.
It's divergent.
1 by root x is divergent. So
it's that.
So that one. So that means you can't.
You can't say.
No. Yeah. So that one is also divergent.
Now this doesn't work over here. So what I'll do is, I will revisit my strategy. Now what I'll do is, can I say x to the power 4? This would be greater than x to the power 2 in this interval.
Yeah.
So x plus x to the power 4 will still be greater than this. So under root of this will be still greater than this.
Hmm.
Yeah.
So 1 by under root x plus x to the power 4 will be lesser than
So
1
won't
by
it
x
be
square.
won't it be root x? Why? How is it still x?
Oh, I'm sorry.
Won't it be x? Sorry.
I'm sorry.
Wait, so how do you know that? Yeah, correct. That's
You have to try to find out a function. That is why this
no.
problem
I
becomes
was saying
challenging.
that you took it as x squared. So
Yeah, because I wanted to come to a function whose nature I know.
correct.
Now I know that when p is less than 1, less than equal to 1, this fellow will diverge.
Yeah.
Sorry, converge. This
So
fellow
it
will.
diverges. Yeah. And it's greater than that. Which
Oh,
means
no,
it
again
diverges.
this will not work. Why? Because less than equal to 1 is divergent, right? So I
Yeah.
cannot still comment on this. Now what I'll do, I'll revisit it again. This is how trial and error will go off. You'll have to do trial and error over here. Abbe. Yeah. Now see what I'll do. Again, x plus x to the power 4 will be greater than equal to x to the power 4 now.
Hmm.
Correct?
Yeah.
Now root of this I can say will be greater than root of this.
Yeah.
So reciprocal of this will be less than equal to 1 by x square.
Yeah.
Right? Now this power is greater than 1. So this converges now.
Hmm.
So
Correct.
this
Yes,
integral converges. This integral converges.
Yeah, so that one also does.
So this will also converge.
So, but that's not the one. That's not your integral. Like that's not the one that we need to.
No, we need to know that only. No, 1 x
So it's
plus.
what? It's x plus x to the power 4, right? That's the one we have to know.
By mistake, I wrote that. This also x power 4.
Yeah. Oh, yeah. Oh, shit. Yeah.
Okay.
Yeah. So it's convergent.
So this also converges.
Yeah. So both of them are convergent. So the sum of convergence.
Yeah. Now, in this case, what will happen? You have to be very careful. You have to try your best to see whether both converge together and both diverge together. Because if one is converging and other is diverging, you cannot comment upon their sum.
Hmm.
Or we can.
You know?
Question is, if one is converging, other is diverging, what will happen to their sum?
Won't it be diverging?
It will be diverging, absolutely. But if both are diverging, again diverging. If both are
Diverging.
converging, then it will be converging. So you have-
Except for
So you have to try your best to check whether both are converging. If at all you are not able to identify such a case, then you have to consider the fact that the integral is a diverging one.
Hmm.
Okay. Let's take questions on this. Which of the following improper integral diverges? Which of the following diverges? Option A, 1 to infinity dx by x square. Option B, 0 to infinity dx by e to the power x. Option C, minus 1 to 1 dx by under root x. Option D, minus 1 to 1 dx by x square. Option E, none of these.
so it's not A or B.
Hmm. No, B.
That's e to the power minus x. Oh no, it could be.
No, it's 0 to infinity, not 1 to.
Yeah.
So don't worry about this. You can actually, for example, this you can actually treat from minus 1 to 0, or let's say k. Okay.
K to 1.
K tending to 1 minus here plus m to 1 limit of m tending to minus 1 plus. Oh, sorry, 0 minus 0 plus.
So that's 1 only. It's 1 only. Oh no, yeah, never. Yeah.
You can evaluate this actually. You don't have to use any rule for this. So what's the answer to this? 2 root x, correct?
Yeah.
2 root x, again k2 minus 1.
That's 2. But then that'll be undifferent.
X, x to the power minus half plus 1. Yeah, x to the power half, minus half. Oh, minus 1 also. It will not exist in that zone only. Yeah? So how can you give it like this? This function will not exist in this interval. So this is absolutely, this is non-existent function. Because when x is less than 0, this will not exist.
Okay.
Okay, so it has to be only this evaluation that we can do.
Yeah.
This part will not exist. So even though they gave you from minus 1 to 1, the function will only exist from 0 to 1 onwards.
0 to 1.
So 2 root x
From 1 to 1.
will be 2 minus 2 root m
minus.
and limit m tending to 0 plus. That's going to be 2. So it converges. So C cannot be your answer. And of course, you also told me about this cannot be an answer because it follows our rule that I told you. So this cannot be an answer. Even this, as I told you, 0 to infinity e to the power minus x. You can evaluate this as well. It will give you 1 by e, correct?
Yeah.
E to the power minus x by minus 1. When you put a very large value, it becomes 0
So it converges.
plus 1 by e. So this also converges, cannot be the answer. D we have to check. Now D is actually 2 times 0 to 1, 1 by x square. Now you'll ask, how did I write it like this? Because I know the graph of 1 by x square is symmetrical about y-axis. Correct?
Yeah.
So you are asking integration from this point to this point. Correct? So you want this area actually. So can I say it's 2 times 0 to 1?
Yeah.
So if this is infinity, even 2 times will also be infinity.
Yeah.
And this fits into my what do you say rule that I gave you, that you had 1 by x to the power p.
Yeah.
Okay, and p is greater than 1, greater than equal to 1. This diverges, right?
Oh, right. Yeah. So
this
D.
will also diverge. So option D is your right option.
Mm.
Is that fine?
Yeah.
Let's take one more. Which of the following improper integral diverges? Which of the following diverges? I have already sent you the assignment for this exercise, right?
Yeah.
Just check whether questions based on this are there or not. I'm actually talking about 60th question in your assignment.
Okay.
But don't look at it, just solve here only.
So you gave till 60th question.
Yeah, this is your 60th question only. Which of the following diverges? I think in most of the cases you can apply the comparison test.
Yeah.
Yeah.
So it's not A, B, or C. And I'm pretty sure it's B.
B.
D for donkey.
This cannot be there definitely.
Yeah, that's what.
It's even A and C is nothing.
How
Because
do you-
it's lesser than a convergent function.
But it's 0 to infinity, not 1 to infinity.
I'm pretty sure it's not that.
So if you break it up from 0 to 1,
1 and then 1 to.
okay. Now see, 1 x square
Is
will
it
be lesser than
divergent?
x, correct?
Yeah. Let it. Mm.
Okay.
Yeah.
But what about
1
1 plus
by
x
x square will be greater than.
square? We cannot comment about 1 plus x square actually. But we can actually evaluate this. This is
Yeah,
actually
just-
tan inverse
just-
x. That's 5 by 4. Correct?
Mm.
And for the
Yes.
other one,
That's
this one I
convergent.
can actually do it. In
So
fact,
it's
even this you
convergent.
can evaluate. Tan inverse x, when you have a very high power, this becomes pi by 2 minus pi by 4. When you put infinity, or when you put a term tending to infinity, it will give you pi by 2. At 1, it will give you pi by 4. So that will again become a pi by 4. So answer is pi by 2. So this also converges. Cannot be my answer.
So you can just use comparison test for the second.
So this is evaluatable. You do not need a comparison test here. But what about this fellow? This
That
we
also-
cannot evaluate. So I can say if x square plus 1. No, I cannot comment like that. No.
So x square plus 1 will be less than x cube.
Now I can do 1 second. 0 to 1 if you break. Okay.
No.
So we know that x cube will be lesser than x square in the interval 0 to 1.
1. Yeah.
So this will be lesser than this.
Yeah.
No, but reciprocal will be greater than that.
So but why break it in the interval 0 to 1? Just do it in the entire interval. Right? In that case, x cube plus 1 will be greater than x square plus 1. And then 1 by x cube plus 1 will be less than.
No, x cube plus 1 will be greater than x4 plus 1 in the interval 0 to 1. Or x square plus 1 in the interval 1 to infinity. But this will be opposite in the interval 0 to 1. See, 0 to 1 you're dealing with fractions, na?
Hmm.
So higher power on a fraction will make it even smaller.
Mm.
That is the problem here. So how do I do this? Here we can apply, I think, comparison test. 0 to 1. 1 by x cube. What happens to this?
It's convergent.
This
It
diverges.
converges.
And 1 by x cube plus 1 is less
This
than
converges or diverges?
Converges. Oh wait.
Check.
0 to 1, so it diverges.
Diverges.
Correct.
So I cannot comment.
Yeah, exactly. So you can't use comparison.
Yeah.
So you can use comparison test for 1 to infinity part, right? Like take it from 0 to 1 and 1 to infinity. The 1 to infinity part is
1 to
is
infinity part is fine. 1 to infinity diverges. Converges.
Converges,
This I
So
can
let's just
say.
assume the other part.
How can
We'll solve the other two and then see if we find one of them.
Can I erase this part?
yeah.
So E can also not be the answer, correct? E can also not be the answer, correct? Will it be? Oh, once again. E can be an answer, right?
It can 0 to infinity.
It's a zero. Yeah, no, no.
Yeah, once again. You cannot claim that. This will definitely converge. Why? Because e to the power x plus 2, 1 by this is less than e to the power minus x. So if this converges, this will also converge.
Converge.
So this
Yeah.
cannot be answered. So I'm trapped between C and E. Right. This you can evaluate
Right.
actually. This
So
can
I
be
think
evaluatable.
I think it'll be
This can be evaluatable. This is going to be this. Okay. 0 to k, limit k tending to infinity. This has to go to infinity. So E has to be an answer. So and only one is correct, right? So we don't need to check for C.
Yeah.
This was a tricky question. Okay.
Mm.
So we'll stop here. Next class, I would do further application, further part of it. Little bit more is left, and then we'll start with definite integrals. Differential equations. I'm sorry, differential equations.
Okay.
okay.
Sir, tomorrow 2 hours and in the night.
Tomorrow, what is the day?
Tomorrow
Friday.
Saturday.
It's Friday.
Oh,
Tomorrow's
Friday. Oh, Friday.
So 1 hour.
Yeah, tomorrow we can have 2 hours. No worries. What do you think?
Okay, so I'm out of station on Saturday, Sunday, Monday.
Oh,
So
tomorrow you're
I'll
out of
try.
station.
Huh?
Tomorrow you're out of
Sorry?
station.
Hello?
Tomorrow are you out of station?
No, tomorrow I'm here.
Tomorrow is what, Friday, no?
Yeah, tomorrow I'm here.
So let's have a 2-hour class tomorrow.
Okay.
Okay.
Timing, morning time will be fine with you. Morning you have a class with me only, right?
Yeah.
8 to 11.
Yeah.
Oh, okay. So we have to have in the night then. Let's have it 8 to 10 in the night.
Okay.
Cool then. Bye bye.
Yeah. Okay. Bye.